हाय एवरीवन, वेलकम टू एप्टी मास्टर। तो कैसे हो आप लोग? उम्मीद करें सब बढ़िया चल रहा है। ओके, सो वी विल सॉल्व दिस बिग प्रॉब्लम। सो कंसीडर इट नॉट ए बिग प्रॉब्लम, वी विल ब्रेक इट इन step by step. Okay, so topic is application of derivatives and it came in JEE Mains 2026 January. Okay, so first read the question. So let f be a twice differentiable function from R to R such that f double prime of x is greater than 0, okay, for all x in R, and f prime of the quantity a minus 1 equals to 0, okay, where a is a real number and the function also has given here, like the function of gx is equal to the f of the expression, like tan²x minus 2 tan x plus a. So constraints are 0 less than x less than pi by 2. Now consider the following two statements. G is increasing in 0 comma pi by 4 and G is decreasing in pi by 4 comma pi by 2. Then we need to select the options. Okay, so first of all, the function given in the problem can be reconstructed. Okay, like g of x is given as f of tan²x minus 2 tan x plus a for x belongs to 0 comma pi by 2, right? So let's break down the problem step by step. Okay, so first of all, what we will do, we will analyze the properties of the fx. So we are given that fx is greater than 0 for all x belongs to R. So this means the first derivative fx is strictly increasing function. Okay, we are also given like this one, f of a minus 1 equals to 0. Because fx is strictly increasing, it must be like, first of all I am writing this, fx is strictly increasing. Okay, so because fx is strictly increasing, so it must be that like fx less than 0 for x less than a minus 1, and f of x is greater than 0 for x greater than a minus 1. Now we will differentiate the gx. Okay, so now differentiate gx. So to find where gx is increasing or decreasing, we need to examine its derivative. Okay, so using the chain rule, gx, what is given here, gx is f of tan²x minus 2 tan x plus a. Okay, using the chain rule we are doing. Okay, dot ddx of tan²x minus 2 tan x plus a, right? So now gx equals to f of tan²x minus 2 tan x plus a. Then we need to do the derivative of it. So that is 2 tan x sec square x minus 2 sec square x for a is constant to 0, right? That is clear to you? Now we can take the common of 2 sec square x, right? So 2 sec square x, then it will be tan x minus 1. And what left? F of tan square x minus 2 tan x plus a, right? Now analyze the inner function. Let the inner function, now for next like step is analyze inner function. So what we will do, the hx equals to tan square x minus 2 tan x plus 1, okay, not 1, it is a. So now we can complete the square to understand its range. So we can do tan square x minus 2 tan x plus 1 plus a minus 1, okay. Now hx is tan x minus 1 its whole square plus a minus 1. So since the square of any real number is non-negative, so that's why this part is always greater than 0, right? So therefore if this one will be greater than 0, then hx should be greater than a minus 1 for all valid x, right? So because the input to f is always greater than or equal to a minus 1, and we established in this step 1, okay, that fx is greater than 0 for x greater than a minus 1. So following that, like consider this part, okay. Now we can write that f of tan x minus 1 this whole square, okay, plus a minus 1, that is greater than 0. Clear? See, fx greater than 0 for x greater than a minus 1. So in the same way, f of this part, like this is greater than 0, this is mentioned, if this is greater than 0 for all x for x greater than a minus 1. So that's why that we can write that f of tan x minus 1 whole square plus a minus 1, okay, that is greater than 0. Clear? Add hx will be greater than 0, and this is greater than a minus 1, right? So we can write this one, okay. Now see, so what we have written earlier, f of this tan x minus 1 whole square plus a minus 1, okay, this bracket closed, that is greater than 0. Now for all x belongs to 0 comma pi by 2 except what, at x equals to pi by 4, where it equals to 0, just put that tan pi by 4 will be what, that is 1, so 1 minus 1 it will cut out, then a greater than 1. So for all x belongs to 0 comma pi by 2 except at x equals to pi by 4, it equals to 0, right? So now we will determine the sign of gx on this given interval. So since, see, like if you will imagine this 2 sec square x tan x minus 1. So since 2 sec square x greater than 0 for like 2 sec square x greater than 0, and we can write f of h of x greater than 0 for our intervals, the sign of gx depends entirely on the term of tan x minus 1. Now for x belongs to 0 comma pi by 4, when this x will be belongs to 0 comma pi by 4, so then just think tan x less than 1, that means tan x minus 1 less than 0. So consequently, like gx less than 0, the function gx is decreasing in this interval. So when 0 to pi by 4, then it will be decreasing. So what statement 1 is there? So statement 1 is g is increasing in 0 comma pi by 4. So that is totally false. Okay. Now if we will consider the like for so this one case, now this for x belongs to pi by 4 comma pi by 2, this range given, right? This range given here, this pi by 4 comma pi by 2, this range. Okay, so now tan x minus 1, like tan x greater than 1, always in this range, right? So that means tan x minus 1 greater than 0. So that means gx greater than 0. So the function gx is increasing in this range, but here it claims that g is decreasing in the pi by 4 comma pi by 2. So that is also false. So both statements are false. So neither 1 nor 2 is true. Okay, so I think it's clear to you. Again, I am just showing you the solution here. If you have any questions, you can just comment below.